Hello there, welcome back for another experiment. I thought we'd have a look at experiment 15. A signal transmission using light. And that's it there. I'll zoom in a bit. Here we go. That's the circuit there. And there's the other diagram. So, first thing we're going to do is the same thing we were going to do with the other board. We give it a good clean, so I thought I'd show you this. These tracks are very dirty, so we'll give it a nice clean with some rubbing alcohol. I'll attempt to do this with one hand. Let's see what happens. There we go. We'll just get rid of all the muck that's on there. God knows how many years. Whoops. God knows how many years since this has been done. Try and do this with one hand. Yeah, that looks a lot better, doesn't it? Right, I've built the circuit and I'm just going to read you the description, what it says about it. The circuit diagram illustrates a typical delay circuit of the kind used for many purposes in modern life. TR1 acts as an on-off switch for TR2. When the switch S is closed, the base of TR1 is earthed so that it does not conduct, and there is no voltage drop through its 10K load resistor due to TR1. TR2 is therefore biased on through the 10K resistor and the 1K coupling resistor, and the lamp lights up. With switch S closed, the capacitor C is shorted to earth so that it contains no charge, and both sets of plates are at zero potential. Goes into a bit more detail there, but I'm not going to read all of that. So let's have a look at the circuit that we made. And this is it here. It's already plugged in and fired up. And it's just a simple little circuit. See, we touched that onto there. And the lights. Then it has the electrolytic discharges. When it's completely discharged, light goes out, charging up the capacitor again. Simple little circuit. But when you're a young lad, all this is very, very fascinating. So there you go, that's one experiment. That was, I've forgotten the name of the experiment now. I've forgotten it now. You'll have to look at the video because it was on there. There you go, that's that one. Right, we have our circuit working, as you'll see in a minute, and it's using a photo cell, which is this part here. You can just about see it. I've got the lights turned out so that it doesn't interfere with the circuit, because we've got that working there. So if you notice, you've got the two bulbs. This one's oscillating and that one isn't, but as soon as you put that between there, you've got both of them oscillating, which means the circuit is working perfectly. Can you see that? Difficult to do this with. Hang on, I'll see if I can get a smaller partition and do it so that you can see. There you go, just about see that, can't you? There you go. Yeah. I'll put the light on so you can see the layout of it all. There we go. Let's put the light back on. And it's not going to work properly now, obviously, because of that. But there you go. I don't know if that's going to work with the lights on. I doubt it. Yeah. Because the sensor, the LR sensor, is picking up the lights from above. So it's not going to work properly now. But there you are. That's the circuit. And that's the circuit diagram for it. There you go. Let's move the wire out of the way. That's a circuit diagram there, using 4 transistors. There you go. If any of you recognise any of this, that's the experiment we've just done, experiment 15. Yeah. So far, so good. Oh, that's sort of working. Yeah, clever, isn't it? So that's basically transistors being used as switches, which is one of their main functions. Right, so this is what it says about the circuit. The circuit in this experiment is similar to experiment 14, except that instead of having a constant LDR exciter lamp, an oscillator circuit TR1 and TR2 has been included so that the exciter lamp switches on and off at the set frequency. A full explanation of how the oscillator circuit works is given in experiment 17. Well, that's it, folks. Thanks for watching. More to come later. See ya.